And we're recording. Okay, so we are going to start. Is it South County Business Park? South, yeah, that's the one in Leopardstown. Okay. Uh, so we were doing functional programmings, all right, yesterday, and Java 8. The functional programming we're going to be doing is going to be built around these ones. Now, functional programming means lambdas, simply put. What's a lambda? A lambda is a shortened version of an anonymous inner class. That's what it is. Okay. So it's built around these 9 interfaces. Okay. These 9 interfaces. The first one is supplier. Now, supplier has one abstract method inside it called get. It has no return type, or sorry, it has a return type T. It has no parameters. Okay, so whatever type you supply it with, the method then becomes, so let's say we supply that with a string, that becomes then string get. Okay, so it returns string. So supplier means it's supplying you with an object. It takes nothing, it supplies you with an object. Okay, what is a supplier used for? A supplier is used for generating objects. Okay, now a consumer takes something, so it takes one parameter of whatever type you want it to be. Okay, so consumer takes uh, one parameter of whatever type you want it to be. Okay, it's return nothing. The method it has is accept. So you avoid accept. If you say type T is a string, then it takes a string. So consumer, think about it, takes an object and it consumes it. All right. Supplier supplies you with an object, produces an object. Consumer consumes an object. The method for consumer is called accept. Then you have BiConsumer. It has 2 generics. Okay. That means it takes 2 objects and returns nothing. Okay. So it consumes 2 objects and returns nothing. Now, they can be the same type or they can be different types. So we'll say that T is a string, U is an integer, then the method accept would be void accept string and integer. Okay. Consumer is usually used for doing something to an object. That's what consumer is for. All right. So a consumer is for doing something to an object. Doesn't return an object. It does something to an object. Predicate. Predicate, it takes an object of type T and returns true or false. The method for that is called test. Okay, so it's returns a boolean, test of type T, can be any type. All right, now what are predicates used for? A predicate is used for testing some condition of your object. Is the person older than 18? Does the person meet the criteria to be entered into our course? Does this car pass the NCT? Okay, they could be all predicates. You're testing an object for something. Does it pass the test? True or false? Okay, you're doing an exam. Does the candidate pass the exam? That can be a predicate. Okay, then a BiPredicate. A BiPredicate is it takes 2 objects. They can be the same types, can be 2 strings, 2 integers, or they can be different types. And it returns true or false. So whereas predicate is for testing one object, BiPredicate is for testing 2 objects. Okay, and the method for that is test. Next one then is function. So think what a function is. A function in Java, you have methods. Other programming language calls their methods functions. Okay, so a function is, think of it as a method. So a function always has a it takes a parameter and it returns a parameter. Okay, so it takes an object of type T, it returns an object of type T. Okay, or type R. They can be the same type or they can be different. It does not matter. Okay, so and the method of that then is called apply. So if you have apply, t is a string, r is an integer. So r, if it returns an integer, it takes a string. Okay. BiFunction then, BiFunction means it takes two objects. Okay. It takes two objects, it returns an object. Now they can all be the same type, or they could be different types. Right? Doesn't matter what types they are. So imagine that t is an integer, u is a string, r is an array list. So your return type is an array list. It takes a string and an integer, and the method for that is called apply. Now, UnaryOperator. UnaryOperator, it has one parameter and one return type. They have to be the same. Okay, so if you define type t to be a string, it takes a string, it returns a string. Now, what's a UnaryOperator used for? It's used for modifying an object and returning that modified object. So UnaryOperator is for taking an object, modifying that object, and returning that object. That's what UnaryOperator is for. Okay, the method for that then is apply. BinaryOperator. It takes two parameters, it returns an object. All right, now you define one type. That means the two parameters it takes and the return type are all going to be the same. So if you define this as being integer, that means it takes two integers and has a return type integer. So you can imagine BinaryOperator, some sort of form of calculation. You're trying to do something with two objects. You're trying to merge two objects into one. You'd use a BinaryOperator. Okay? Is that okay, everyone? Right. Now, all of these are used in conjunction with streams. All right? That's why we're learning them. All right, so streams are going to be using all these methods. All of these methods takes at least one of these. Some of the more complex methods takes 3 or 4 of these things. There's one called merge all, I think it's called. It takes 6 of them. Okay, it takes 6 different arguments. And it's probably the most difficult method I've ever come across anyway. All right. But majority of them are not that difficult. All right, so that's why we have to learn all of these. Okay. So the first one we did is supplier, and we just did an example here of supplier. Public class employee t implement supplier. That's what it looks like. Public t get return an object of type t. Okay. Now, so a supplier. Let's go to it here again. It returns an object of type t, and it takes nothing. Okay. So what does the supplier do? Supplier creates objects for you. That's what it does. Okay, a supplier creates objects for you. The most common method we're going to be used with supplier is for each. For each takes the supplier object. Hold on. No, sorry. Generate. Okay, it's going to be a method called generate that takes a supplier. There's also something called iterate that also takes a supplier. Generate is used to create an infinite number of objects, and it takes a supplier object. Okay, iterate is used for iterating through numbers usually. So here I created a supplier. I haven't given it a type. Okay, haven't given it a type, so that means on the right hand side you can put any object. So supplier sup doesn't take any arguments, it's returning that string. Okay, you don't have to put return. If I have brackets in my lambda like so, then you have to put in return. Okay, but as I don't have curly brackets in my lambda, you don't need a return. In actual fact, if you put in return and if you don't have curly brackets, it's going to be an error. All right, so there, this is a supplier. What does it do? It produces this string. Now, something that I didn't emphasize yesterday. Now, all of these lambdas, all lambdas have what is called lazy instantiation. All right, remember that guy? Lazy instantiation. Now, what's lazy instantiation? If I do this, okay, that's not lazy instantiation. We create a dog reference and we create our dog. So our object is created at that point. Yes? Okay? It's created whether we need it or not. Is that okay, everyone? Right. What lazy instantiation is that the object is not created here. It's only created when we call the method of the lambda. In this case, supplier, the method is get. Okay? So this supplier object is not created till here. Does everyone understand that? Yeah. So this is what they call lazy instantiation. Lazy instantiation is only creating objects as you need them. All right. Whereas if you just go dog spot is equal to new dog, it's created straight away, regardless whether you want it at that point or not. Okay. Lazy instantiation means you only create it, or you only create it as you need it. All right. So it's not created here. It's created here when I call the get method or the apply method. What's the other methods? Now, you do need to know these methods. Okay, the supplier has the get method. Now, both consumers have accept. Predicates, both predicates have test. All the rest of them are apply. All right. Now, I frequently forget those. I don't know how you're going to remember them. So maybe it's just by virtue of the fact you get used to using them. Okay, you have to know all of those off by heart. All right. Supplier uses a get. Both consumers use accept. Both predicate uses tests. The remainder uses applies. Okay. Let's go down here. So now here we haven't supplied a type. So that means on the right hand side, you can have anything. Okay. Now, problem with that is, of course, is that so sup.get, that is an object reference to a string object. So that means you only have access to the methods of the object class. Okay. So if you do this, supplier string str sup. Okay, so this is a supplier. We've supplied it with the type of string. Okay, so then I go, same thing here. I put in supplier, takes no parameters, and it returns, it has to return a string. Now, when I go str sup.get, that produces a string. Okay, that guy produces a string. That's what that produces. Sup get up here, that produces an object reference to a string object. Whereas down here, this produces a string reference to a string object, which means we then have access to all the methods of the string class. Is everyone okay with that so far? Yeah? Right? So a supplier produces a string. That's a string reference to a string object. That's what it produces. This guy here, this produces an object reference In this case, it's a string object. Okay. Now, so what I did then was I created, so this is going to produce a random number between 1 and 100. Okay. So then I went supplier of type animal. So that means that the lambda on the right hand side is going to produce an animal. It's going to produce an animal reference to an animal object. That's what's going to be produced by the lambda. All right. So what does it do? It goes new animal, and this number is going to be different each time. Okay, each time I run the program, it's probably going to be different. Now there is going to be times, as it's between 0 and 100, there is going to be times when it produces the same number. All right, there's a 100 to 1 chance, but if you run it 1,000 times, you're naturally going to get some repetition. All right, so now again, the animal is not produced here. That's not where the animal is produced. The animal is produced when you call the method of the lambda, which in the case of a supplier is get. Okay, so we have animal sup.get. This is lazy instantiation. That creates the animal at that point there. Everyone with me so far, yes? Okay, so all of these lambdas use lazy instantiation, right? It allows you to create objects as you need them, which is a big bonus, all right? Before, if we were creating animals, let's say we might want an array with 1,000 animals, or we might not. Before, we'd have to create that array of 1,000 animals whether we needed them or not. Okay, by using this method here or something like it, you can set up in such a way it'll create the array of 1,000 animals only if it's needed. So it does also increase the speed of your program. Okay, now, so a supplier is anything that's creating everything here. So a supplier's main functions for creating objects and particularly using function stream.generate to create an unlimited amount of objects. Okay, so I think I have one done here. Yeah, I'll do that in a second. Now, so here we have a supplier that creates a local date. Okay, so it's going to be a local date. So it takes nothing. And what does it return? It returns local date.now. Okay, local date.now is today's date. Okay, now this is exactly the same as this. Okay, this is the double colon operator. Now, how does it know that all this works right? Well, for a start, so it's sup d1. So sup d1 is a local date. Okay, it is a local date and it is a supplier. So Java sees that first of all, this is a supplier, which means it takes no parameters. Okay, and it also sees is that it's a local date. Okay, it sees that it is a local date. So local date.now is a static method. So you can shorten that further to that. Now, if you never want to use that syntax, that's fine. Okay, but just to tell you, this is the syntax they're going to use in the exam. All right, that's the syntax they use in the exam. Now, you don't have to, if you in your personal life, I was going to say, you in your programming life never want to use that, it's fine. You can use that syntax instead. But just to note in the exam, that's usually the syntax they use, which is why I have to use it as well. Okay, that is not any more right than that. It's just a shortened way of doing it. That's all it is. That's why I'm going to be doing that as well for most of our functional programming. I'm going to be using something like that. Okay, so That is exactly the same as that. Now, we haven't created our local date there. Okay, our date is not created quite yet. Where is the date created? Let me show you the date is created. When I go down here and I go sup d, put in a print statement, sup d1 dot get. That's only at this point is the local date object created. Should run. There it is. Now, yes, it's in the American format, but the next chapter is actually about dates and times. So dates and times are easy enough in Java 2. It's more revision than anything else. And the only thing that's different is the time zones. Okay. Now, so we've seen there how to create a local date. So let's create an animal. If I go like this, Supplier animal A1 is equal to new animal, or you can also go A1 is equal to animal new. Okay, they're both the same thing. Now the animal is not created until you go A1 dot get. Okay, so animal only created at this point. Now it's the same thing for create an array list. So I'm going to create a supplier that creates an array list. And I'm going to say array list. Now I haven't said what type. You can also do something like this, an array list of animals is equal to now I have that imported. Okay, why is that giving me an error? Give me a second here. Oh yeah, supplier, so I'm going to call it sublist is equal to new array list animal. Okay, so that's a supplier to create an array list. You can also do shorthand for that is equal to all right, they're both the same thing. Now usually when you're creating an object, it's usually calling a method. All right, when you're creating an object, you're usually calling a method that's maybe connecting to a database and populating all the fields of your object with variables from a database. Okay, it's usually not that simple. Okay, so both of these are the same, and the array list is only created when you go sublist.get. Okay, so array list only created at this point. Now, I'm going to create a list with a couple of strings in it. Okay, so I'm going to get list string. I'm going to call it names is equal to arrays dot as list. I'm going to add a couple of names. Just add your own name, Mary, Pat, Sean, and Sarah. And I'm going to create a new array. I'm going to create another array list with supplier. It's going to be a list. I'm a list of strings, and I'm going to call it sup list string. It's going to be new array list string. And you can do stuff like this. Right, so I'm going to go sup list str dot get dot add all names. Okay, now this is real functional programming. All right, functional programming always consists of methods calling methods. So this guy here, that produces an array list of strings. Now that produces an empty array list of strings. Okay, that produces an empty array list of strings. This one here then adds all of the names into this empty array list of strings. Yes? Okay, this is how functional programming works. It's this guy here, you have to know sublist.get, that produces an empty array list of strings. All right, so that produces an empty array list of strings. So you can call all the methods of the array list class. One of the methods of the array list class is add all. Okay, so you have to get used of that syntax. You have methods calling methods. That is functional programming. All right, that's all it is. It's methods calling methods. But you have to know that this guy here produces an array list. That means you can call methods of the array list class. What am I doing? I'm adding an existing array list to the array list that's produced here. Is that okay? Right. Now, next thing I'm going to do is I'm going to show you methods that can take supplier objects. All right. So I'm going to go down here to the so we're outside of EX1. So this is, what is that? Is that EX1? This is EX3. So end of EX3. Okay. So we're going to create methods here. So these three methods take supplier based objects. Okay. Now, so the first, so they're all going to be static methods to make them easier to call. All right. So the first one, static. It's going to have type T, void, take supplier. It's going to be called. And what does it do? It takes the supplier object of type T, and I'm going to call it simply S. Okay. So we define a supplier object to be of type T. Let's say this guy. Okay. So that means that T is then going to be a list of strings. Or if we send it this object here, that means that type T is going to be an animal. Whatever type we give supplier here, that's what T becomes here. All right. So the type is not set. It is whatever type you supply it with here. If I don't give it a type, well then type T is going to be an object. Yes? Yeah. 182, yeah. 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 Well, right, so that's the return type. All right, but that's a local generic type. Okay, type T, that means that that's going to be wherever we use T inside of this method. Let's say if I send it, so let's say I'm going to be sending it this guy. All right, that means that this guy here is going to be an animal. Okay, if I send it this guy, okay, that means that type T is going to be a list of animals. Okay, now, so we're going to show you how these operate. So we're just going to put in here, I'm going to say take supplier method, and it's inside here we're actually going to go s.get. Okay, so that's what creates our object. And then I can go, this is a, and if I go plus s.get class get simple name. Okay. So we're going to be sending a different supplier objects. It's going to create whatever it is. So we're going to be sending it that guy. No, not that guy. We're going to be sending it that guy. We're going to be sending it that guy. And we're going to be sending it that guy. Okay. So go down here. I'm going to go take supplier. And first thing I'm going to send it is I'm going to send it an animal supplier object, which is M1. So this is using animal generic type. Then I do another one. Take supplier. I'm going to pass it this guy, sublist. That is going to return an array list. So this is using list generic type. And what else do I have here? I have a date, sup D1. Sup D1. This is using local date generic type. Okay, so if I run that, so this is an animal, which is, so the first thing I have sent, it says this is an animal. The second thing is this is an array list. The third thing is this is a local date. Okay, so now, yep. Well, no, the only reason I made it static is because then oh, if that wasn't there, then what would happen is if you're taking a supplier object, so if I do that, you can't leave it in another place. Yeah. Now, if you do that, that's going to be an object reference to. Yeah. Yeah, you do. You can't have it in one without the other. Well, now you can have it there. Okay, so you can have it just there. Now that means that T is going to mean inside when I send it an animal, T is going to be an animal. Okay, but it's not going to be supplier. So you can do that by itself, but you can't do this by itself because it doesn't know what T is. Okay. Now, of course, the problem with this is, I see s.get, it only has access to the methods of the object class. Okay, because type T can only be an object reference to a string, an object reference, so an object reference to an animal, an object reference to a list, an object reference to a local date. All right, so it doesn't know, it doesn't have any methods of the animal class, it doesn't have any methods of the list class, it doesn't have any methods of the local date class. Okay, so instead of that, let's say we want to do this. So I go static void. Okay, I'm going to call this take supplier 2, and I'm going to go supplier. I go here, I go extends animal, and I'm going to call this S again. Now, what this can take a list of animals, or it can take a list of a subclass of animals. All right, now what does that mean? So if we just go to animal here, I'm quickly going to create 2 new classes. And I have another one. Oh, I already have a dog somewhere. Hamster. Okay, so class hamster extends animal, class cat extends animal. Okay, now that means that this method here can take a list of animals, a list of cats, and a list of hamsters. Okay, so put it in here. This can take a list of animals or one of its subclasses of cats or hamsters. So this can take a list of animals, it can take a list of cats, it can take a list of hamsters. Now if it takes a list of animals, those animals can contain both hamsters and cats and animals. Do you understand that? Okay, so if it's a list of animals, it can take a mixture. If it's just, it can also take just a list of hamsters. It can also take just a list of cats. Yes? Okay. Now, they're animal references to a hamster object. They're animal references to a cat object. Now, if there's a particular method of the cat class you want to call, then you can send it a list of cats. Yeah. Actually, yeah, that won't work. Sorry, I stand corrected. That doesn't work. All right. I'll come back to that in a second. Okay. Now, notice the question mark here. All right. You can only use this syntax really in method signatures. Okay. You can't use that syntax here, for instance. Okay, it's only for usage really in methods. You can create a, for instance, an array list of that type, but it wouldn't really make sense to do it. All right, where you really use that syntax is there. It's in method parameter lists. That's where you use that guy. Now, so that can take a list of animals, a list of hamsters, or a list of cats. Yes? Okay. Now, this one here, static void take supplier. So it can take supplier 3. So supplier, and we go and it's super animal s. Sorry, it's not a list, it's a supplier object. Now, this line here, this can take a supplier that was defined with an animal or with the superclass of an animal. Now, it can take a hamster or a cat. All right. So this can take a supplier with a superclass of animal type or animal type, but not a hamster or cat. Now, the list itself can take hamsters and cats, all right? But it can't be, the supplier object can take, if it's a list, for instance, it can take hamsters and cats. I suppose the best way to show you is if I try to create objects and send it to it. All right, take supplier 2. I'm not going to do anything with it. I'm just going to print it off. And this is take supplier 3. Okay, quick question. Why have I done 3 different named methods? Why didn't I do them as overloaded methods? Remember what overloaded method is? An overloaded method is a method of the same name and return type, but it's got a different parameter list, right? Do those 3 methods have a different parameter list? Actually, they don't. All right. Well, if I create a supplier with an animal, okay, it can use, so let's say they all have the same name. All right, you can see we're getting errors there. If I create a supplier with an animal, it could use this one. It can use this one. So this can use any type. So that can use an animal. If I create a supplier with an animal and send it, it can also use this method, because question mark extends animal. That means it can use an animal or a subclass of animal. So it can use that one. It can also use this one, because this means a animal or a superclass of animal. So they aren't different enough to be overloaded. Okay, and if I have a supplier object that's created with an animal, it can use that guy, it can use that guy, and it can use that guy. It doesn't know which one to use. That's why I call this one take supplier 2. I call this one take supplier 3. Okay, yep. 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 Yeah, but no, because see, if it's type T, doesn't know what type it is. Well, see, you haven't put any. No, no, because it doesn't know. You see, because right. So here, type T means anything. So what's common across every object? The classes of an object. So you can't call the string methods because you might be sending it a cat. You might be sending it a database object. Now here is different. We have access to the methods of the animal class. So I should be able to go s.get.drink and eat. Those are the methods of the animal class. Okay. Likewise here, now, okay, yeah, you don't have access to the methods of the animal class here, okay, because you can only take animals or superclasses of animals, all right? So you only have access to the methods of the object class here, which is fairly important. Simple name. So this guy here have access to methods of animal class. Have no access to methods of animal class. Okay, so this guy here can take a supplier. So I'll create a couple of supplier objects for take supplier 2. Okay, so if I go take supplier 2 can take an animal. So go here. So let's take supplier 2. So it can take an animal type. Take supply. So I'm going to create a supplier hamster ham sup is equal to new. Okay, so I can take that guy, take supplier ham sub, no problem with that guy either. I can go supplier cat sub is equal to cat new. I can take that. Take supplier cat sub. Now our hamster is not created until here. Okay, our hamster is not created until it goes down here. Our cat is not created up here. It's created all the way down here. All right, so these lambdas, these functions, okay, they allow you to create objects in all sorts of places. You don't have to create the object. You only create the object down here. You're creating the object as you need it. So hamster's not created here. Not created here. It is created in the take supplier 2 method. Now the reason I'm showing you all of these is that when you come to doing streams take all of these sort of objects. So you have to know how to send these or how to send these objects to methods. And most of the methods use this one. Okay, that's the most one that's used in all of the streams. When you be looking, we'll have to start looking at the method signatures. You'll see if you define your type to be an array list, you'll see question mark super array list. You'll see question mark super string. That's the syntax they use most often. Okay, now so what can be sent to this? So I can take supplier and 1. Take supplier 3. Okay, that works fine. So this can take a supplier object with a animal or a superclass of animal. Okay, so it can take that guy, and 1 is an animal. Okay, now if I try to pass it one of the hamsters, it might compile, but it should give us an error. So I'm going to try and pass it hams up. Okay, doesn't take a hamster. Doesn't take a list, or doesn't take a supplier created with a hamster. It also doesn't take cats up. That doesn't compile either. So can't take a supplier object created with a hamster or cat. Right? So these two will not compile. So up to now, we only have to consider, right, we have an object. Is this object a dog, a cat, an integer, a string? Now you have a couple other things to consider. Okay, you have to consider what the generic is. It's a supplier object created with a hamster generic. It's a supplier object created with a cat generic. It's a supplier object created with a list of strings generic. It's a supplier object created with a list of animals generic. It's a supplier object created with an animal generic. All right, so it's something else you have to consider from this moment onwards when you're doing methods. All right. Now, the last thing in this particular section I'm going to show you is an example of a stream. Right. What takes part 3? Yep. Yep. Or a superclass of animal. No, but well, because it's right. So this returns nothing. Static void takes supplier 3. And what does it do? It takes a supplier that uses the wildcard for superclasses of animals. Okay, so that can take a supplier object that was created with the type animal or object, because animal only has one superclass, which is object. Okay, now I'm just going to show you an example of a stream here. So let's see. I'm going to create a array list of cats using a supplier object. So array list of cats, I'm going to call it cat sub list. I need to import array list. Sorry, I'll make it a list. Make it array list, fuck it, makes a difference. I'll import it. Bollocks, what have I done wrong there? Let me just see, I've done something wrong there. Right, what I've done here is I've created a supplier object, and the type we're going to create the supplier object is with array list cat. So that means that this supplier object is going to create an array list of cats. Yes? Right, now, it's very simple. It's going to be, this is the syntax I'm going to use because we need to get used to this syntax. So I'm going to go array list cat new. I'm only using that so we can get used to it. All right. Now that's the exact same as this guy. Okay, it's exactly the same as that. Okay. Now, okay, so this is going to be one line. I'm going to explain it line by line. Okay, it's one line, but I'm going to split it up. So I am going to go, I have this right. So cat sup list dot get. Now that will produce our array list. Okay. Just make sure I have this right. Okay, cat sup list dot get. Now that will produce an array list. From that, I'm going to use something called a stream. Okay. Now, from that, I am going to use something called, come on, focus. I have this right. Change that a bit. There we go. Go back to that again. So I'm going to create array list cat list is equal to cat sup list dot get. Okay, so that creates our array list of cats. Okay, now I'm going to use streams. I'm going to go stream dot generate. Now, if I type in generate, I know you can't see it from there, but by typing it up, you'll see that it takes a supplier of type T. Okay, I haven't defined what my type is, so it can take a supplier of any object. So, generate is what we're going to use. So it takes a supplier object. What's the supplier object going to do? The supplier object is going to generate cats. Blank. So I can go cat new. Okay. Now, what generate actually does, generate produces an infinite amount of cats. Okay. Generate takes a supplier, but it produces an infinite amount of cats. And we don't want an infinite amount of cats. So when you're using generate, you nearly always use limit with it. Limit. So generate produces a stream, which means you can then call all the methods of the stream class. So one of the methods of the stream class is called limit. Now limit produces a stream, but it takes a number. So I'm going to limit it to 10 cats. Okay, and then I'm going to go for each. Now for each takes a consumer object, which we're going to be doing in a minute. What I'm going to do inside there is I am going to go catalyst add. So what that does is it generates an infinite stream of cats. We don't want an infinite stream of cats. So it generates an infinite stream of cats, but it produces a stream. So we're going to call limit. Now limit also produces a stream, and it takes a number 10 that produces a stream. Now for each doesn't produce, for each returns void. But what do we do for each one of them? We add a cat to our list. So now we have a list of 5 cats, 10 cats. Now you don't have to understand that quite yet, but that's what we're going to be doing tomorrow. Okay, so what does that produce? This produces so this produces 10 cats that are added to our cat list. Okay, now I've used the shorthand here. The real reason to use shorthand really is not to make your life more difficult. Is that if you're putting a full lambda in there, code can get very cumbersome. Right? So the reason to use double colon notations is to make your life a bit easier. All right. Sure, I'll do it. Yeah, sure, I'll do it. Stream dot generate. You could go right. So we can put in L so for each takes and then we go that's it. Change that to my cat so we can clearly see it's a cat. Okay, that's the longer version. That's the shortened version. It's not an awful lot shorter. Okay, so they both do the same thing. This produces 10 cats that are added to our cat list. So this also produces 10 cats that are added to our cat list. Not a loop inside. Okay, before we'd have to create loops, not anymore. Okay, there is. Okay, to prove that there is, what's the fucking thing, that count, isn't it? How would you get the amount of things in a size, is it? Yeah, it is true. So we should have 20. Yeah, there we are. 20 cats. Okay, so that is a short form. That is the longer form. Okay, if you want to use the longer form, by all means, it's not an awful lot longer. No. No, because, right, so stream.generate, that produces a stream. So you can call all the methods of the stream class. Limit produces a stream, so you can call on the methods of the stream class. Now for each produces void. So for each is something called a terminal operation. That actually finishes your stream. Okay, these guys here, that is something called a intermediate operation. That really isn't a stream operation at all. Okay, now that's what I'm just showing you an example of generate takes a supplier, limit doesn't takes a 10, for each takes a consumer object. That's a consumer object. Okay, so generate takes supplier, for each takes a consumer. That's the way you need to know it. And after using them for a while, it does become second nature to you. All right. First few times you're going to be using them, you're going to find them very awkward. But as you get used to using them, they do become easier. Yeah. Well, you see, the thing is, when you're using streams, you usually use them with something called a terminal operation, and that means when you use a terminal operation on a stream, the stream is finished. That's it. Okay. Now you can do stuff to this, all right, but you usually use stream with something called a terminal operation, and when you use the terminal operation, the stream is finished. Yes, Igor. Your question? Which one? No, it's not actually. No, it's not needed. No, no. I'm just showing you that that one is the same as that. Okay, so just put it here. This is same as the above line. Okay. Now, so yep, this one 205. That one. Yep. Yeah. So that guy is a terminal operation. Yeah. Yeah. No, 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 because the stream is separate from the list. The stream is operating on the list. So it's a separate object. Okay. Now there is something called a parallel stream. You can create something called parallel streams. But I can be doing those for a while. Right. So that is supplier. So the next type of functional interface we're going to use is static void ex4. This is the consumer. So this is ex4. Well, as this guy, this is the consumer functional interface. Now I'm going to go to astronaut, and I'm going to go here, and I'm going to give it type there, and I'm going to say implements consumer why is that giving me an error there? Oops, sorry, wrong place. It should be here. Right. It should be fucking there either. should be here. Right. Now, so astronaut. So consumer takes an object, all right, and produces nothing. All right, so it consumes an object. So you're not returning something. Okay. So C astronaut. For class implementation. Of the consumer. And this is what it looks like. So public class consumer, public interface consumer. Okay, consumer T void except TT. Right, so what do you use it for? So here's what it's used for. So it can be used when a object needs to be consumed without returning any result. So what's the most common thing we do in Java? We've done it, the very first thing we actually did was an example of something that's consumed and doesn't return result. A print statement. Okay? Print statement. So, input. Printing out an object. That's an example of when you'd be using consumer object. Alright, so we're going to follow the same format as supplier. Now, we've done supplier, so everything that applies to supplier also applies to consumer. Okay? Same. And the method of supplier is accept. So, I'm going to go here. I'm going to create the simplest form of consumer. So it's consumer. And I'm going to call it C1 is equal to. Now, it always takes an object. Now, you can do this, or you can put brackets around it. Either way is fine. Okay. Equal to, this is simple consumer lambda x. Okay, hold on a minute. All right, so if you do that, right, now why is that? Something wrong there. Give me a second. Oh yeah, shit. Hold on. All right. So that's the simplest form of. You should be able to put these here. Yeah. Okay. So you can put brackets around it if you want, or not. Makes a difference. Okay. So consumer takes an object and doesn't return anything. Now remember, print statement isn't returning anything. Print statement returns void. Okay. So that is okay. This is wrong, by the way. Now, why is that wrong? Why is that showing me an error? Yeah, because we're saying there it's returning a string. Okay? If you just put in any variable, let's say a string or a new cat, we're saying it's returning in. Okay, I don't know why that shouldn't be the case. Oh yeah, that's not returning the cat. Right, sorry. So right, that's wrong because that's returning a string. Okay, so that's incorrect. All right, so a consumer, this will not compile. A consumer takes a variable and returns nothing. Okay, okay, so this one here, what's this one? Takes an object of any type and prints it out, but returns nothing. Okay. So if I want to call this, I go C1 C1.accept. I'm going to send it an animal, and it's going to have an age of 3, the name of Andy. Now, so that creates an animal. It sends that animal to here. It prints off simple consumer lambda plus x. So, and then it's going to print out all the details of the animal. So to prove that it does, go back here to main. I go to examples are ex4. So we get simple consumer lambda, animal age is 3, name is Andy. Okay? Any questions about that? Okay. Now, so that's without an object. That's without, now that means that X can only call the methods of the object class. Okay, so you nearly always provide, you very rarely do that. Okay, if you don't provide a type, that means X is an object reference to an animal, or X is an object reference to a string. Okay, so X will be a object reference to a animal, and X will be a object reference to a string. Now that means that X only has access to the methods of the object class. So you usually go consumer string. And I'm going to call it con str is equal to. So we're simply going to go str, and we're going to print off the string sy. I quite simply put in the string there. Now we can write the shorthand for a consumer. Okay, you can write the shorthand for the consumer. It's simple as this. So this is system.out.println is a static method. So you can do this. All right, that guy is exactly the same as that. And frequently, when you're printing off a stream, so for each use takes a consumer object. Okay, for each takes a consumer object. If you just want to print off the contents of an array list using a stream, That's what you use to print off the contents of the string. Okay, using for each. Put for each system.out double colon println. Okay, so these two are the exact same. They both print out string. So very simple. All I do is constr.accept, and here is my string to print out. There it is. Okay. So that shortened version is the most used shortened version of the whole lot. Okay. You use it with the for each. For each, it'll print off. So let's say you do a stream that's going to produce 10 cats that are going to be added to a tree set that's going to be organized by their age. And it's also going to remove duplicate cats with the same age. Okay. And then at the very end of it, you have a for each. You just put that in. It'll print out all the details of those 5 cats. Yeah. Okay. Right. Now, a consumer, if it takes an object, it can do as much as you want with that object. So it takes an object, it usually does something with that object. All right, that's what a consumer is for. So it consumes an object. A database connection. Database connection doesn't necessarily have to return anything. Connecting to a file doesn't necessarily have to return anything. If you just want to, I don't know, change an object in some format, you can use a consumer object to do that. Okay, so what I'm going to do here is I am going to create a consumer object that takes an animal. Now that animal can be an animal, or it can be a hamster, or it can be a cat. Okay, so it can be any of those. I'm going to call it conAnimal. Is equal to. Now I'm going to do the long form lambda here. So I am going to say, now you can do that, animal ND, but I'm just going to go ND. Okay. I'm going to go here, and this is the long form lambda. Now, this returns nothing if you don't have any return statement in it. Okay, so what I'm going to do is I am going to just print off the method conAnimal consumer called, and I'm going to print out the details of the animal. So ND. I'm going to call a method of the animal class .drink, and I'm going to change the age of ND. ND.age is going to be equal to, oh shit, I can't access the age. No, I can't. Don't bother that stuff for now. So Andy's going to eat meat. Okay, so you can see here that it's a consumer object. So Andy is going, it prints out the details of Andy. Then Andy drinks, then Andy eats. What else can an animal do? Let me just have a look, see. Is a method called takeString. We don't give a shit about that. All right, so we can see here that we can call all the methods of the animal class. So what does a consumer object do? A consumer object can do things with the animal. Okay, if there's 50 different methods of the animal, you can call all 50 of those methods. Okay, so a consumer object is for doing things with your object. That's what it's for. Okay, it's not for changing the object. Sorry, for changing the object is going to be the UnaryOperator. Okay, it's not for changing the object. It's for getting your object to do things. Okay, so what's consumer for? So here, that allows our animal to call all the methods of the animal class. So consumer allows an object to do things or call all its methods. Okay, so to get it to call its methods, all I have to do is, so I am going to go con animal dot accept new animal. I'm going to pass it in an animal that's got an age of 5 and the name of Angela. Okay, so by doing that, it calls all of that. Now, of course, any of these things can be done with methods as well. All right, so this will send this animal to this will call the drink and eat method for Angela. I'm going to call this one a different name. We'll call it M1 to avoid any confusion. M1, and this is M1.drink, and M1.eat. So run that. So it prints off all the details of the animal. Age is equal to 5, name is equal to Angela, animal drinking, I eat meat. Okay, any questions on that? No? Okay. All right, so we're going to create a couple more consumer objects before we finish them. So we are going to create, if I go con animal again dot accept. Now I'm going to create a new animal. Now inside, for creating the age, I'm going to put in this guy. That's going to create a random age between we have too many things in there. I'm going to give it a name of Andy. And next the bracket. Okay, so that creates an animal with a random age between 1 and 100. It passes it to here, then it calls all this method. Yeah? Yes? Okay, now remember that this doesn't assign the animal to anything. Okay, so the consumer doesn't create an object. Can create an object inside. So this an object is created, but it's not saved anywhere. All right. So consumers are also another way for you to automatically create objects that disappear as soon as the code is run. Understand that? So guess what? They're also very secure. So This creates an animal, sends it to here, does its stuff on it, and then it's gone. Okay? So it is ultra secure. It's a way to quickly create objects that cannot be hacked. They're gone. So it creates an object, it does its work on it, it gets rid of it. So consumer creates objects here that cannot be accessed once run. It can do all the methods, you can access all of the variables of it or whatever you want. Okay? But as soon as you run it, that animal is gone. As soon as you run that, the animal is gone. Okay? So if you want to create an object and you just want it to be available for a couple of milliseconds to connect to a database, and then you want it gone, that's how you do it. Okay? Any questions on that? Now I'm going to take a break because I fucking need it, I think. Okay? So wait 5 minutes and then go for your lunch. All right? So I'm going to load up that video.